Hello friends, this video on chemical bonding part 14 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 13. Let's take example of CO2 molecule. So carbon has 4, oxygen has 6, there are 2 oxygen, 6 into 2, 12, 12 plus 4, 16. I have 16 valence electron. To start with, let's add like this carbon. So if we add like this, so we used how many? 2. 2 into 2, 4 electrons. So we are left with 12 electrons. Let's make the carbon happy first. Carbon has 4. Let's add 4 more. Carbon is happy. So we are left with 8 electrons. This guy, oxygen, needs 6. This guy also needs 6 because both have 2 electrons. So 12 electrons are required. We have only 8. Not possible. So we have deficiency of electron. So let's propose this new model now, where I have one bond here. So let's start with the fresh approach. 16 I have 3 bonds, 6 electrons gone in 3 bond, 10 electrons remaining. Let's make carbon happy. Carbon has 6 electrons, give 2 more electrons to carbon. Carbon is happy, 8 electrons. This oxygen needs 6 electrons and this needs 4 electrons. 6 plus 4 electrons is required, but we have only 8 electrons, so this also won't help. Let's draw a new structure. So we can draw true structure now, right? Because you have to draw one more bond here. So one we can do is we can add extra bond. I'll draw the same structure first here. One case I can do is I can add extra bond here. The other case I can do is I can add extra bond here, right? 2 possible options I have. Let's take these both options and let's start fresh again. You have 16 valence electron now. You have 4 bonds, 8 electrons gone. So you have 8 electrons now. Let's make carbon happy. Carbon is happy in both the case. Let's make oxygen happy in this case. Oxygen needs how many? 4 it has. It needs 4 more. 4 remaining. 4 remaining we can give it to this oxygen. This oxygen is also happy. We have 0 electrons now, everybody is happy. Let's take this case. So we have 16 valence electron minus 4, 8 electrons gone for bond. So we have 8 electrons. Carbon is happy, not required. This oxygen needs how many? 6 electrons. So we have 2 electrons remaining. So this 2 I can give it to this oxygen. This guy will also be happy. I have 0 electrons remaining and everybody is happy. If you see this structure I could have done in this fashion also. Correct? Where I have 2 here and 6 here. Because if this guy is oxygen 1, this is oxygen 2, oxygen 1, oxygen 2, oxygen, oxygen 2. So they give me 3 scenarios. 1, both double bond. This case, oxygen 1 and carbon has single bond. Here oxygen 1 and carbon has triple bond. There are 3 different shapes for CO2. And that's why we see that resonance occurs. Resonance exists in this case also. So the best shape to give CO2 will be like this. The resonance shape. Correct? Also, since we have already studied the formal charge, let's find the formal charge in all these cases. Case 1, oxygen has 6 valence electron, minus 4 here, minus 2 bond, 0 charge. Carbon has 4 natural form, minus 4 bond, 0 charge. Oxygen, this guy, has 6 natural form, minus 4 electron now, you can see here, minus 2 bond, 0 charge. So everybody is 0 charge. Let's take this one here. In this case, oxygen 1, 6 is the natural form, minus 6 it has here now, minus 1 bond. That is minus 1 charge. So it will get minus 1 charge. Carbon has 4 in natural form, minus 4 bond, 0 charge. So oxygen 2, 6 in natural form, minus 2 here, minus 3 bond here, is plus 1 charge. So this guy is plus 1 charge. Similarly, if you do, this guy will come out to be plus 1 charge, there will minus 1 charge. So this is just to show that the formal charge is something easy to find. Let's draw a structure of NO2 minus. See, nitrogen has 5 electrons, oxygen has 6. So 6 into 2 because 2 oxygen molecule plus 1 extra charge, 1. That is, we have 18 valence electron to start. So let's draw the structure. Nitrogen, we put some oxygen molecule here. Since we have used 2 bond, 4 electron is gone, or 2 bond, left with 14 electron. Let's make nitrogen happy. It has 4 electrons. Give 4 more electron to this guy nitrogen. It will have nitrogen. 8 electron, nitrogen happy. Now we have 10 electrons. Let's make this oxygen happy. Give 6 electron because it has 2 electrons. Minus 6 to oxygen 1. We have 4 electrons, but we need 6 electrons to make this oxygen happy, right? So it will say, okay, let me form a double bond with nitrogen. So let's cancel this structure and create this structure. Let's start fresh again. We have 18 valence electron. We have used 3 bond. There will 6 electron is gone in 3 bond. Right? We are left with 12 electrons. Let's make nitrogen happy. Nitrogen has 6 electrons. Give 2 electrons to nitrogen. Nitrogen is happy. 10 electrons are there. This oxygen has 2 electrons. Let's give 6 electrons to this oxygen. This oxygen will be happy. We have 4 electrons. This oxygen has 4 electrons. It needs 4 electrons to be happy. And thus, I don't have an electron now. And everybody is happy. Right? There's a minus charge. Let's see from where it came. Let's see this oxygen. This oxygen has, let's find the charge on this. So oxygen has 6 by default, the natural form, the natural valence electron. Minus 6 it has now. Minus 1 bond. This guy has minus 1 charge. Let's talk about nitrogen. Nitrogen has 5 in the natural form, minus 2, minus 3. There is 0 charge. This oxygen, let's talk about this oxygen. 6 in the natural form, minus 4 electrons here and 2 bonds here. So 0 charge. So this is the only charge it has, and that's why it got a minus 1 charge. 1 minus charge. But you notice here, instead of making this structure, I could have made this structure also. Correct? So thus if you see that both the structure is possible. Thus resonance exists here also. So the nitrogen resonance structure will be something like this. Correct? Let's take one more example of HNO3 nitric acid. So here hydrogen has 1. Nitrogen has 5, oxygen has 6, but the 3 oxygen atoms, so total is 18 plus 19 plus 5, 24. So let's take nitrogen as my central atom, and we can add 3 oxygens and 1 hydrogen here. Correct? We are starting with 24, we have 4 bond, 8 electron gone, so we have 16 remaining. Let's make nitrogen happy. Nitrogen is already happy. 8 electrons. Let's make this guy happy. Oxygen. 2 electrons. We'll add 6 more. This guy is happy. Let's make this guy happy. 2 electrons. 6 more. This guy is happy. Let's make this guy happy. To make this guy happy, you need 6 electrons, but we have only 4. That means this structure is not possible. Right? So let's do one thing. We know that it's acid, nitric acid. So OH exists in that case, right? So let's, instead of writing that structure, let's create this kind of structure. OH. And then I have one O here, one O here. Because I know for acid, OH exists. So let's try with this structure, right? The structure is gone, waste. So we started with 12 valence electron. So we have 1, 2, 3, 4 bond. This 8 electron is gone here. So we have 16 electrons now. Let's make nitrogen happy. Nitrogen has 6. Add 2 more. Nitrogen is happy. We have 14 now. Let's make this guy happy. Oxygen. So this has 2. Add 6 more. So 8. Let's make this guy happy. This oxygen. It has 2. Add 6 more. We have 2 now. So can we make this oxygen happy with 2? No. Right? Because it needs 4. That means a double bond has to be formed. So let's start with a new structure where I am forming a double bond here. Let's start with this structure. Right? Let's cancel this. So just hit and try, you keep trying. So we have 24 valence electron. So we have 1, 2, 3, 4, 5 bonds. So 10 electron is gone in 5 bond. So we have 14 electrons now. Let's make nitrogen happy. Nitrogen is already happy. Let's make this oxygen happy. This is 4 electrons. So let's add 2 more electrons. Sorry, 4 more electrons to this oxygen. Oxygen is happy now. So we have 10 remaining. So let's see this oxygen. It has 4 electrons now, right? So let's add 4 more. This oxygen is also happy. So we have 6 electrons remaining. 6, if we can give this electron oxygen, this will be happy. So we have 0 electrons and everybody is happy. This is my shape of HNO3. But wait, if you see the same HNO3, we can also make something like this. Right? This is also possible. Correct? I think let's try with this. I'm not sure if it's possible or not. Let's give it a shot. 1, 2, 3, 4 OH. Let's try this. In this case, nitrogen. Let's see. Let's start with 24. We have 10 gone, 5 bonds. So we have 14 now. Let's pick nitrogen is already happy. Let's pick this oxygen happy. We need 6. So we have 8. Let's make this nitrogen happy, oxygen happy. We need 6 more. 2 is left. We can make this oxygen happy with 2. Right? So this is also possible. So we have 3 possible shape for HNO3. That means here also the resonance exists. So none of these shape will give you exact picture of nitric acid. I think the exact picture is something like this. We'll have nitrogen, oxygen, nitrogen, 1 oxygen here, 1 oxygen here. Then you can have something like this. Some resonance. Correct? Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.